This conference will now be recorded.
Hello, everyone. This is Eddie Gonzalez. I'm a program manager with the Society of American Military Engineers. I have the pleasure of working on our college engagement and our student engagement efforts, and especially working with our virtual student chapter on these professional development webinars. I'm just going to start by giving a little housekeeping of how the webinar is going to go, and then I'll turn it over to our facilitator. We will have some interactive components to this webinar, and there's two methods that you can use to engage with the presenters. One is through the chat function or the chat box that's in the GoToMeeting platform. Just feel free to type your questions in as you get them. We'll likely hold some of the questions until the Q&A part of each presentation, but if there's anything that needs to be addressed during the presentation, I'll make sure to chime in and convey that. There will also be an opportunity where I'll unmute everyone's lines to be able to provide interaction through the phone call. I will ask for those of you listening in, if you can mute your line unless you're speaking. That way we can cut down on the background noise that the microphones pick up. I also was asked to start off this webinar with giving some context as to why this topic was selected. Over the coming year, the Society of American Military Engineers is going to be developing an engineering competition to really foster engagement by our student members. The competition is going to be organized to address one of 14 grand challenges that you'll hear about in this webinar. The idea is to really utilize the innovative thinking that our student members represent to be able to start thinking about solutions to some of these issues facing our world. And we really are excited to deploy that out as an opportunity for our student members to really show where their training and academic experience has taken them. So we really look forward to putting that together, and you'll learn more about that as the year progresses. For now, I'm going to turn it over to the webinar facilitator, Homer Guy, who's on the leadership team of the Virtual Student Chapter, and he'll present the rest of the content and introduce the rest of the panelists. So with that, I will turn it over to Homer.
Great. Thank you, Eddie. Well, thanks everyone for joining us. This is the second in the series of the virtual student chapters. As Eddie, as we're going to discuss a little bit later, we're putting these on YouTube so that you'll be able to go back and look at certain things or to pass them on to some of your friends. As Eddie said, I'm Homer Guy. I'm the moderator for this virtual student chapter presentation. And the topic is addressing our planet's grand challenges, which are the 14 crucial challenges facing every conceivable type of engineer, scientist, architect, designer, futurist, anyone interested in solving truly large, wide-ranging, and complex problems. I'm a retired Air Force civil engineer. I'm a registered architect and a professional engineer, and a fellow in the Society of American Military Engineers. And in 2012, I was lucky enough to win the Society's gold medal. I worked for a company called Bristol Bay, which is an Alaskan Native corporation. By the way, and as Eddie kind of pointed out, if you do have any questions, please submit them through the chat box, the little cloud in the upper right-hand corner of your screen at any time. And we look forward to your comments. We'll address those as appropriate. Next slide, please. Throughout history, engineers, scientists, architects, and designers have been solving civilization's challenges. Today and in the near future, we're facing some new challenges, and the National Academy of Engineering and National Science Foundation identified the 14 challenges to the engineers that focus on sustaining civilization's continuing advancement while improving the quality of life. There are really 4 themes that are essential for humanity to flourish: environmental sustainability, health, reducing our vulnerability, and adding to the joy of living. And as you can tell by the website at the bottom of the page, This website gives you far more information and in-depth information about these topics, so that if you're interested as a student in basically kind of figuring out what you want to do with your life's work, I would encourage you to take a look at that, because it gives an idea about both the nature of the challenge, why it was selected, as well as why it's important for civilization. By the way, I'm going to use the word engineer throughout this presentation as a shorthand way of describing problem solvers, whether you're an engineer, a scientist, a designer of any sort. And after all, engineers and those people that I just described are really designers with passions that use their creativity, imagination, and experience to really solve the problems. Next slide, please, Eddie. The 14 grand challenges, here are the first 7 of them. They were formulated by world experts from the sciences, and they were peer-reviewed by more than 50 world subject matter experts. So there's a lot of validity to these. These are the top, well, of course, these are 7. These are half of them. But as I pointed out a little bit earlier, the website really gives you a more detailed explanation of the individual topic and challenge. So I really encourage you to take a look at that. Next slide, please. Here are the remaining 14 challenges. And since publication of the 14 challenges, findings have inspired numerous global challenge events and summits. And these, by the way, were formulated in 2017 and published in 2017, but still fired up and still has initiated a large, wide-ranging initiatives around the world. And as Eddie Gonzalez pointed out a little bit earlier, it inspired a Society of American Military Engineers competition as well. So I encourage you to take a look at that when that's revealed. Next slide, please, Eddie. The purpose of today's presentation is not only to introduce the 14 grand challenges facing the world, but also to get you to think about the tools that you'll need to solve some of the world's challenges. I think especially as you talk to the panelists or hear from the panelists today, you're gonna realize that creativity, that understanding of multiple cultures and how people perceive things, taking a multidisciplinary approach rather than thinking in terms of just a specific discipline, using an entrepreneurial and a business mindset, and really developing an understanding of social consciousness is going to be key for you, not only to win a competition or to participate, but also to be successful in your own education and in the world that you're soon going to be entering, both educational as well as a work experience. All right, next slide, please. Today, we're going to use a panel discussion format for this presentation. During the panel discussion, we'll look at the challenges from perspectives that maybe you might not have thought about. You'll find that from listening to the panelists that no engineer or designer works in a vacuum, and technical solutions have to consider economics, social, legal, humanitarian, and political ramifications. So we're pleased today to have Mr. Clayton Perry, who's a fellow in the Society of American Military Engineers, a council member for the city of San Antonio, and a longtime member of FSAME to participate. We've got Ms. Christine Lertz, who is a project manager and a registered interior designer and a member of Society of American Military Engineers for Merrick and Company here in San Antonio. Mr. Ben Matthews, a professional engineer and a fellow with the Society of American Military Engineers from Jacobs Company. And finally, I'm Homer Guy. Next slide, please. We're going to introduce you to our first panelist, Mr. Clayton Perry. Mr. Perry is a council member for the city of San Antonio. As I mentioned, you may not realize that San Antonio is the 7th largest city in the United States, but Mr. Perry has a limited time today, so we're going to ask him to go first and talk about these challenges from his perspective as both an engineer and a politician. And we're going to let him drop off because Thursdays are always a city council day, so he's between council sessions. Mr. Perry is a fellow in the Society of American Military Engineers and a former Air Force civil engineering officer. He served for 21 years in the Air Force as a civil engineer. He earned his BS in building construction from Texas A&M University. And oh, by the way, that was the first time I knew that I was going to get a whoop on it from him. That was the first time that I had not heard a whoop after I said the word Texas A&M. And he also earned a master's degree in aerospace technology from Embry-Riddle. He's worked for not only the Air Force, but also for large engineering firms prior to starting his political career. And as a city council member, he has to deal with many of the grand challenges already on a daily basis. I think you're going to be surprised when he talks about some of these, because these challenges are already here. There are already things that he has to deal with. So in his role as a politician, he brings not only an engineer's thought process to problem solving, but he's one of the few on city council that asks the question, well, what's the requirement? What's it going to cost? Or what's the impact of this? So he definitely brings a different mindset to it. So as I'm proud to say that as a politician, he's consistently tackled. By the way, he didn't tell me to say any of this, but I've known Mr. Perry for a number of years and have watched him here, and he's consistently tackled the complex problems and asked the tough questions that others are not so inclined to ask. So I think the nice thing was that his constituents, or his neighbors, as he says, reelected him earlier this year in pretty much a landslide victory. So that's a good testament here to his value and his character. Well, engineers are often accused of ignoring public opinion in politics and being apolitical. So I'd like him to kind of set the stage with several questions about where politics and engineering kind of intersect. So as the first question, Mr. Perry, how did your engineering background prepare you for a political career?
Well, thanks for that question, Homer, and thank you very much for the introduction. Really appreciate that. I'll just get right into it. What the things that we bring to the table, of course, is problem solving. We got communications, we got collaboration, and strategic thought. And all four of those really bring to the table in the political arena that thought process, the organizational skills, the things that you really need to be able to communicate and collaborate with your other council folks. And that goes for any political position, whether it's at the state level or federal level or here at the local level. So all of those things really come together very, very well at in the political realm, because let me tell you, a lot of folks don't have those qualities that you learn through school, and then through your internship, and then through your jobs on your day-to-day business. And a lot of folks don't get that. And that's one of the big issues that I have on city council, is trying to deal with someone we've had folks that's never even had a job before. And, to try to show that that skill level or that knowledge, and try to explain that to someone that doesn't have that or those skills, it's very, very difficult. And that's where your communication and collaboration comes in trying to explain things and make them understand to agree with myself on council. So it fits very, very well on that engineering, architectural, the sciences. That all comes in with critical thought and being able to ask the right questions. And I have found that very, very interesting on being on council. You get a lot of staff recommendations and people coming in with what they want, what they need, but you have to be able to quickly analyze what those recommendations are and think them through and ask the right questions. If you don't ask the right questions, you're going to get bad advice. You're going to get you're going to get something that you weren't expecting. And so again, that engineering expertise, that critical thought, and the communications, it all comes together very, very well in the political realm.
Oh, thanks. It's kind of curious that you think of the profession of engineering as being one of the most respected professions in the U.S., typically in the top 3 or 4, and you think about the profession of being a politician as being somewhere in competition with telemarketers and used car salesmen for being the least respected professions. Would you? I think that a lot of the especially students that are thinking about a career in engineering, probably not thinking about a career in politics. Would you recommend a career in politics for a young enthusiastic engineer or person involved in the hard sciences?
You bet. And I'm really working hard to try to change that perception of what a politician is. It took me a long while before I could even call myself a politician. I'm using terminology now because I've had to accept that, even with the baggage that comes along with it, of the perception that it's not a good profession, and I don't like to call it a profession. I like to call it a service, and that's what I'm all about. And there needs to be more engineers and those critical thinkers in those positions. I don't know what the current statistics are today on how many engineers there are as politicians, even up at the congressional level. But let me tell you, we're full of, and I don't want to take anything away from the legal career, but I think there's way too many lawyers involved in our politics, and we need more engineers. We need more military veterans. We need more leaders in those positions. And as engineers and architects, you are leaders out in the field, and that's what we really need in politics. We got a lot of folks, like I mentioned before, that has no experience, has no leadership qualities, has no critical thinking, collaboration, those kind of things that you deal with on a day-to-day basis as an engineer. We need that desperately in our political realm. It's sad that we're going through a lot of this negative publicity about politicians, but that has to change, and part of that changing process is getting the people that can communicate and collaborate on getting problems solved out there. And that's what it's all about. And sending your as I call neighbors out across the city. So absolutely, I would recommend it to any engineer. And to tell you the truth, every group that I get in front of, whether it's an engineering group or a veteran group, I keep beating that drum. I say, you have got to get involved. You don't have to run for a political office. Get involved at your neighborhood level and be an activist. There's that kind of carries a negative connotation also, but I never considered myself an activist, but I became one in the neighborhood and looking out for my neighborhood, getting upgrades, getting agreement across the neighborhood, what should be done or shouldn't be done, that kind of thing. And it's very, very critical that we get the right folks in those positions to, lead our government throughout. It's just really sad what we have, and it's a poor reflection on the really quality people that are serving in a lot of these offices that are really trying to solve those problems on a day-to-day basis.
Yep. Thank you. By the way, I Googled the number of engineers in Congress, and it's about 3%. So
yeah, that's really low. I think if you Google how many lawyers, you're going to get probably 90%. I did learn about veterans. We have 17% veterans in Congress, and even to me that's still low, because again, those leadership qualities that we really need in those positions.
Yeah. Hey, what advice would you give to a student who's thinking about a career in engineering or the sciences or architecture or design?
Well, number one, those careers are always going to be needed. And if you look around our built environment, whether you see it or you don't see it, underground versus above ground, it's always going to be needed. That requirement will always be there. And what I tell groups that I get in front of, again, engineers or contractors, construction companies, that kind of thing, I said, look around. Just look around at the built environment. You should be proud of what you're doing. You should be proud of what you've built, because everything out there you're responsible for. You put your fingerprints on, the roads, the buildings, the underground water services, sewer services, all of that. It has our fingerprints on it, and everybody should be proud of it. But hey, it's always going to be needed. And so, yes, that brings job security, and it is a great career to get into.
Thanks. I promised you that I would get you off, out fairly expediently here, expeditiously.
No, that's all right, Homer. I can go a little bit longer.
Oh, okay. Well, I'm going to skip to. I gave you a question about. Going to ask you a question about the military members. Really are really known for being apolitical. And how difficult was it for you to make the transition from being an apolitical military member to someone who is so heavily involved in the political process?
Well, for me, it was easy, and I think everybody is a little bit different in being able to make that transition. For me, it was easy because as a civil engineer in the Air Force, it's all about customer service. And for all of our careers, it's all about customer service and dealing with the customer, satisfying their requirements, and making sure that they're taken care of and that they're happy. So that's really the same mantra that I used in my political career. It's all about customer service, knowing what the requirements are, doing a good, thorough, concise budget, and what those require. How much is it going to cost? And to your point a while ago, Homer, that is my big thing. Is when they come out with these big requirements, I want to see costs attached to it. I want to know how much the taxpayer is going to have to fork over to pay for projects here in the city. But again, it was an easy transition for me because I looked at it as an extension of service, what I did in the Air Force and through my private companies that I work for. It's all about the customer and taking care of the customer. So it was easy for me. And it started off, I got involved in just what I was talking about. I got involved in my local HOA. I was on the board. Then I became the president. And then I got involved in city boards and commissions, and it just all fell in line. And then the opportunity came up to run for city council, and I said, heck yeah, I think I can do that. Well, I know I can do that. I've done it my whole career. So it was an easy transition for me, and it would be for anybody if you remember your core values about customer service, service before self, and that's what a political career really is as well, just as much as it was in the Air Force. So easy for me. I'm sure it's not that easy for some folks, but that was kind of my guiding principles when I started running for this office.
Yeah, I think I've known you for 30 some years, and
Yep.
I'm not sure that I would have probably picked you. I mean, you certainly were personable. You had customer service skills. You had good personal skills and whatnot. But I don't think I would have picked you as a politician. So I'm glad that and then the reason I say that is life often has interesting twists and turns, and maybe the way that you, especially as a student or just getting started in a career, think about their career, they probably don't realize that it's not going to turn out exactly like they might have anticipated, but it's probably going to turn out better because they've learned more about the world around them and what they're really interested in.
That is so true, Homer, and I've been blessed in my career and now in my political career. I've truly been blessed, and I've been given great opportunities, and it's all how you use those opportunities and how you keep looking forward to the next opportunity and what you're going to be doing. So I've really enjoyed it. I love what I'm doing on City Council right now. I'm looking at other opportunities as well. I mean, you've got to be doing that for your own career advancement as well as learning. And I learn stuff every day, and I really enjoy that.
Well, that's great. Well, I'll tell you what, we appreciate you being on. I'm gonna let you drop off if you want to, or you certainly can stay. I'm gonna go ahead with the panelists. I just checked if anybody has any other questions here. We've got some good input from Ruth Mower, who's talking about Environmental Law Institute, and we'll kind of save that until a little bit later and kind of recap it. So, if Clayton, if you want, you may drop off, but if not,
well, if there's any questions, be happy to answer any questions. If not, I think I'm going to bug on out of here. But I really appreciate this opportunity. I hope I shed a little bit of light on what I've gone through and what we really need to do as the engineering community to work on those global problems and come up with solutions. Yeah.
Well, thank you. We appreciate the time that you've taken, and best of luck to you in your political career. And of course, as always, we'll see you around campus.
All right. Sounds great. Thank you, Homer. Appreciate it. And thank you, everybody, for attending.
Take care. Thank you. Well,
bye-bye.
Our next slide, please. Our next panelist is Ms. Christine Lertz, who's a project management professional, LEED accredited professional, registered interior designer, and a member of FSAME. She's American Company's project manager for Antarctica, of all places, and she's done task orders totaling over $400 million in construction costs. She's traveled to Antarctica with her clients to witness operational procedures to best understand the needs for managing facilities and doing so remotely. She's managed design projects for the federal government over the last 10 years and has led efforts to incorporate technologies used at McMurdo Station in Antarctica into federal government facilities for asset management, design development, and construction management. She's a graduate of Purdue University and has over 25 years of experience in the architect engineering industry, recently accepting an American Council of Engineering Companies National Excellence Award for the Antarctica LIDAR project. Christine, life in Antarctica poses grand challenges of its own, doesn't it? What have you learned about tackling those large Antarctica problems?
Homer, I honestly, the biggest thing I've learned is just to think outside of the box. There's so many unique challenges due to the location. It's the most remote location in the world. And as the project manager, I watched some super smart engineers come up with ways to make things work. They considered things I'd never even think of. For example, we wanted to run some utilities through a crawl space of a new building so they would stay warm. But we have to be careful about heating that crawl space to keep them warm because the heat would radiate down and melt permafrost, which then causes movement of the building foundation. So just a, trickle down impact. The unique location also further emphasizes the importance of quality assurance, QA/QC on designs too. If something went wrong and our design was wrong or something changed, there was an unforeseen site condition, a contractor doing the building can't just run out to the Home Depot to pick up missing parts, right? So we had to be really, really careful and really pay attention to those kind of things. So as you kind of alluded to in that introduction, thank you for that, by the way, one of the cool projects that came out of that was we used LIDAR, which is light detection and ranging. So it's basically scanning, and we scanned the existing conditions at the site in Antarctica when we were there. And that way, when we were back in the office designing, if we wanted to zoom in and take another look at a spot and see how our pieces would fit, we pulled up this really cool 3D file that showed exactly what it looked like, kind of like when you drop a pin on Google Earth. So, the biggest and best thing about it is just learning all the different ways people think outside of the box.
Great. Hey, since you've been to Antarctica and worked there, which of the grand challenges most interesting to you, or which do you think would have the most impact upon the Antarctic?
It's really cool since the National Science Foundation is part of generating these challenges, and they are actually my clients on all of this Antarctica work. They run the research stations down there for the United States. So it kind of made managing work to provide infrastructure and facilities for scientists who are working on all of the challenges. So kind of tied up in a nice circle there. Not surprisingly, several of the challenges are applicable to my specific work, and those include access to clean water, enhanced virtual reality, restoring and improving urban infrastructure, securing cyberspace, and in general, engineering the tools of scientific discovery. So those have the biggest impact, but all of them have relations to the work that we're doing down there.
Great. How do you approach those large-scale and really complex problems that, such as the grand challenges or some of your Antarctic challenges? Oh, by the way, we caught that pun about cool and Antarctic.
I almost had no pun intended, but I did mean it.
Yes.
I've been trying to think of a better word to describe it, but it just is really cool. And I know it sounds cheesy, but that's the case. And anyways, in answer to your question, actually, I was thinking about this, and we don't really approach it too much differently than the smaller projects. All projects have a baseline amount of work. You set them up, you get your team going, you plan out what your end result and your deliverables are. And so on a large scale, complex project like this one, it's phased and it's, 20 years worth of work. It's important to continually keep up the communication and break off the tasks into smaller, more manageable pieces. And then most importantly, make sure that all of the tasks are being carefully coordinated. The most important thing on projects of absolutely any size to me is setting expectations. Clear communication about what is expected by a client or a professor or anyone who's getting the results of this work and what will be provided, those set the stage for a smooth running project. Any project with problems that I've seen in my 25 years of experience, pretty much all of the problem has related to a misalignment of expectations. So for a big one like this, or, for the grand challenges or my project or any project, I think it's just to make sure you take the baseline steps and then the coordination and communication between all of the people participating.
Yeah. How how important is collaboration in your problem-solving projects?
Oh my gosh, it's just immensely important. It's a basic requirement. You can't build and design anything or research anything in a bubble. You know, I was thinking an example. So say I need to get a water line to a building in Antarctica. Your first thought is, okay, well, that's the civil engineer's job, right? Well, no, not only him. They need him, yes, but they need a structural engineer to provide pipe supports. We need a mechanical engineer to determine the flows and the pressures of that water. Depending on the type of water, I might need a fire protection engineer. And so it's really, really energizing to me when I see all of these folks get together to try and approach a problem and solve a problem like that. They all bring a unique perspective to it, you know. It's just really, really interesting. You can't run that pipe through an area because the permafrost, and we can't answer the anchor support, says the structural guy, or the mechanical guy says, well, the slope is wrong and you can't get the flow properly. So you wouldn't have thought about those things if you were only thinking in your discipline. So not only is it important to collaborate within your team, it's important to collaborate with your client as well, or whoever you're providing the solution to. So keeping them informed of the progress and your ideas and what you're going to go down a rabbit hole and research and design, letting them know what's going on keeps you from going too far down the road with an idea that they don't like, or they can say, you know, we've tried that before, it didn't work. So it just, again, what I said about expectations, keeping everyone informed and everybody aware of what's going on in the project in general just allows those expectations to remain attainable.
Yeah. How has your creativity really enhanced your problem-solving skills and capabilities?
I have to tread lightly here because you and I, Homer, we're architecture background, right? Which is a little bit of difference in engineering in terms of creativity. And that's my humble opinion, but I'd be willing to venture that any engineer or architect working in the industry now would agree with me. It's kind of a joke amongst us that engineers tend to be a little more rigid and, you know, they plug numbers into a calculation and they come up with an answer. And for me, with my architecture background and as a project manager, I come up with ways to approach a problem that might, as I mentioned before, be a little bit outside of the box. I'm, you know, never asking engineers to not run calculations, but I'm coming to the table maybe with a different approach to meet a deadline or to get a solution, to get work done in a shorter period of time. So don't get me wrong, engineers need to be creative when they're coming up with the design ideas on which to run calculations, but it's just interesting. You know, every project or problem that you approach, you have to have a little creativity to come up with the idea that you want to hone into your solution in the first place.
Yeah, I think that, you know, we're not giving a plug for architecture school, but I do think it was probably easier for me to go from architecture. You know, I started out in architecture and then went into engineering. It was easier to do that than to go from engineering to architecture. But I
Homer, I'm going to take myself off of mute pretty quick. I know I'm the next speaker, but we'll defend engineers pretty soon.
But let me finish the sentence here before before you chime in, Ben. But
I think
that, but I do think that you know, in order to be successful, you know, in solving the grand challenges here, there's going to be a lot of creativity that's going to have to be, and a lot of, as you said, you know, Christine, thinking outside the box and all, as far as, you know, solving these problems. You know, they're going to have to be, it's not going to be, you know, and to say that engineering is just about plugging in, making calculations is, you know, just not true. But
I mean that.
you're really going to have to come up with alternatives. You know, you're going to be good at thinking. You know, you got to be more than a one-trick pony. You know, you've really got to think outside the box. Okay, Ben. Okay, tell us what you think.
No, I completely agree, and obviously we'll get a chance to get into my slides and overviews a little bit more. But thanks for setting the table for me.
Okay, great. All right. Okay, I'll tell you what, Christine. As your last question here says, we all can learn to be better, learn to have more creativity and to be better problem solvers. What would you tell yourself as a student that was just starting out, or somebody that really wanted to think about improving their problem solving skills or tackling some of these world problems? What advice would you give to your to a younger you? Not that you're old, of course.
Yeah, careful. You know what? Hang out with people you respect, whether it's your peers or professors or people with more experience than you. Their ideas and processes are going to rub off on you. Don't be afraid to ask questions. You have to advocate for yourself because no one else is going to do it for you. When I decided I wanted to go from architecture to project management at my firm, I literally knocked on the door and set up meetings with 13 different people in my firm. And it was because I wanted to ask them what it was like, how they approached it, how they solved their problems. And I wanted to make it known that I was in the market to become a PM, a project manager. So I was advocating for myself. And I think they eventually let me do this job just because I was pestering them so much. But I learned a ton from those 13 interviews and from those people before I even set foot in the position that I have now. In addition to hanging out with people you want to be like when you grow up, make sure you step outside your comfort zone and challenge yourself. That's really how you get better. I remember the literal day one of managing my very first Antarctica project, and I worked all day, and I went home, and I was so overwhelmed that I couldn't eat, and I felt nauseous, and I couldn't stop thinking, oh my God, what have I gotten myself into? But I took it step by step, and I approached it in an organized way and leaned on and, collaborated with teammates and other people within my firm. And it turned out to be the most interesting experience of my career. And it afforded me travel available only to a small group of people in the whole world. So it's made me better at my job. It's shown me great experiences. And I could have remained doing things that I've been doing for years, but look what I would have missed. So don't be afraid to ask questions and to challenge yourself.
Yeah. All right. Well, thank you very much. All right.
Sure.
Next, we're going to go on to Ben Matthews here. Next slide, please, Eddie. We've set the table for Ben here, and he was chomping at the bit to talk. So this is his big opportunity. Ben has been a FSAME member for 15 years and is really a unique. He's one of 5 members to have become a fellow while still a young member. He's a distinguished graduate from the Air Force Academy and earned a master's in construction management at the University of Texas. He's a licensed professional civil engineer in Ohio and Texas. Now, while in the Air Force, Ben served on the FSAME Young Member Council as secretary, and then after leaving the Air Force and transitioning to the private sector in about 12 years ago, Ben served as the National College Outreach Committee chair, and for his college outreach and young member council efforts, he earned the President's Medal in 2010. Ben has been the post president for Dallas and led the Dallas Post to distinguished post status. He's a leader in the private sector as well as serving as the federal client manager for Jacobs Engineering with clients truly around the world. Well, Ben, before I let you talk about the things that others have said, I want to give you a question here. The Whole Foods CEO, John Mackey, said that the quality of his decisions improved when he heard dissenting positions from his staff that really identified flaws in a particular decision. How important is it to pick good collaborators, and how do you really find those people? How do you find good teammates and all to help you solve some of the world's great challenges?
Yeah, thanks, Homer. I also appreciate the introduction. And this question about collaboration is really just what Christine has talked about, just what we've had with our nice little ebb and flow, give and take between architects and designers and engineers. By putting us all in the same room, that is the collaboration that takes place. And you see it in, besides the architecture engineering industry, you see it with the technology. If you look at, some of the early partnerships of major technology firms that exist today, like, Google and Microsoft and Apple, there's often a very technical engineer like Steve Wozniak, and someone who's still kind of engineering, but more of a designer and innovative with Steve Jobs there. So that happened with many aspects of our companies. Many successful companies that you see today had that as the foundation. Getting people with differing styles and different personalities coming together. I would say that technology, whether it's Christine's LiDAR that she talks about, or other different aspects of 4D and 3D building information models, it's really reducing the stovepipes that we've had between engineers and architects and forcing the collaboration. That's forcing the civil, mechanical, and fire, and even the environmental aspects to all work together for the purpose of one overall model. And it happens. Last thing I'll say is it happens even more so from just us and me as a designer, and Christine as a designer. We're collaborating more with constructors and builders now, partnering up with a construction firm to help work on the Air Force Academy Cyber Center. It's a new development that they're trying to put together, a requirement out there. It happens to be one of our 14 grand challenges of securing cyberspace, but that's an example of taking the designer and the builder and putting them in the same room as early as possible to try to figure out a way to get it done.
Yeah, that's it. As problem solvers, we typically follow define the problem and look for potential causes and identify alternative approaches to solve those problems, and then we kind of think about it and select an approach and pursue that approach. But some of the world's problems are so large that even defining the problem is a huge task in and of itself. How would you start to define some of the greatest challenges identified by the National Science Foundation's 14 challenges?
Yeah, I like what Christine also said a little bit in this area of really, treating it in a way like a small project. The principles that you have for large projects, whether you're breaking them down to smaller tasks or putting them together, are very, very similar. Getting the right team aligned, getting the right objectives. For me personally, it goes back to putting it on paper, taking that large grand challenge, and an exercise that you can kind of look up on the internet is mind mapping, and it allows to go from that core problem and seeing where you go into other areas and what makes up that core problem. Next thing you know, you have octopus tentacles going all over your paper, and the outer parts of those tentacles often turn into the foundation tasks of where to start with some of your things. And it kind of turns it in from a large overarching problem to some smaller issues. It's very similar to just taking your given find solutions like you have in school there, of trying to work through things. But lots of different techniques out there, a lot of technology companies that are trying to cut through some of the challenges. There's been management techniques about failing fast, of trying to brainstorm and taking through an idea and saying, hey, if this doesn't work, we want to know as soon as possible so we can move on to the next idea. And this virtual student chapter that we have here in this forum is really not as large as the grand challenge, but sometimes feels a little bit of a challenge to try to break that down and figure out ways that we can create value for the students that are listening to this.
Yeah. The Society of American Military Engineers' strength really comes from the partnership, and the basis of it is really the partnership between the military and the private sector. You've been on both sides, and you're a leader in the society. What role can the military and the private sector really serve in solving some of these grand challenges, do you think?
I think it's already underway, to be honest. There still is tons of improvement. I mentioned the Air Force Academy Cyber Center. Well, they're copied. The West Point already has a cyber center underway, and the Naval Academy has a cyber center underway. They each want to produce the best and brightest students in this space. But another thing that the Air Force has that I've been pretty keen on is the AFWERX program. AFWERX is the program that they're trying to set up in tech places, incubators in the DC area, but in Austin and Las Vegas, to try to reduce the bureaucracy of the military to solve these problems. So it brings together the military side, it brings together academia and industry to solve various complex innovation challenges. And one could say that, it's about half of the things that are related to the grand challenge list that we see it here. Where does FSAME play in my mind? FSAME is the incubator. It could be the incubator like AFWERX, coming together and really showing what those organizations of military, academia, and industry can do together if we all start rowing the boat in the same direction.
Great. All right. Thanks, Ben. I'll tell you what, I'm going to ask Eddie to give us the last slide here while we recap some of the questions. Ruth Mower has had some really good questions about water quality being part of the grand challenge, and yes, it is. We definitely encourage you to look at the website that the National Science Foundation has. And Eddie, you might want to, one of Ruth's questions here says, after what is the time period for when the contest rules and details will be released, and is the target audience student FSAME chapters to compete? You want to address that, Eddie?
Certainly, yes. The plan is, well, first, our student chapters are a target audience. We have been looking for a program that, as a national organization, we could provide to all our student chapters for them to engage their members and have an opportunity for them to use the competition to increase student participation and get more student members into the society. The time frame is, this will be a competition that will be deployed during the 2020-2021 school year. So we hope to have everything developed and defined by the end of the summer with the announcement sometime in fall. The competition would run through about the March-April timeframe of 2021, where we will then have a selection process to identify projects that are going to be recognized at the JETC conference in Portland, Oregon, in May of 2021. Two things to highlight, though, about the competition that we think makes this really unique among other competitions. One of the priorities is going to be to look at the multidisciplinary nature of these solutions. Because of the nature of the grand challenges, we know that there's going to be a social science component, a impact to society component. These aren't just going to be technical solutions. So we are going to be looking for projects that bring in social science, law, business, into their project designs. The second piece that we think is going to make this really unique is we really want these projects to represent research and development that then would be of interest to private industry that wants to take those ideas and potentially bring them to market. So we hope outcomes of the competition would be patents, industry relationships, and even actual solutions that can enter into the marketplace that had a genesis through a student chapter. More to come. We're still at the concept phase. We'll be convening an advisory group in the spring to bring some more definition to this, and I'll be communicating this through all our student chapter network and through our student members about the details as they become confirmed.
Great. Thank you, Eddie. And I'll tell you what, we're still open for some more questions. Probably the best is to use the chat box. While that's going on, Ben, would you close by explaining some of the goals of the virtual student chapter and what you'd like to achieve in the coming year and years?
Yeah, thanks, Homer. And again, I really appreciate you pulling this panel together and this discussion. It is about these grand challenges and trying to reduce silos and look at various tools that we have. And I kind of, alluded to it when I said, I took the virtual student chapter problem and tried to break it down as well. And, Eddie mentioned the physical student chapters. We're doing great with our physical student chapter. There's, anywhere from, 30 to 40 in any given year, depending on how robust they are. But there's currently over 2,000 student members out there across FSAME that might not have a physical student chapter. So that's what this virtual student chapter has kind of created, is a home. It's a boundaryless organization that we're trying to do. We're going to use the Slack platform. It's been pretty active. So those same tech companies that I was talking about a little bit earlier kind of use that to get out of the email silos that take place, but it allows the communication to take place both up and down in terms of questions for mentors. If you have questions for Christine or I or Homer, we can answer some of those questions about where our respective careers, but it will also allow you to collaborate from a student peer-to-peer level as well for maybe ideas around these grand challenges or other things that might be taking place throughout your careers, or having one student chapter success ideas, or those that might be wanting to start a student chapter. The good news is this Slack platform really allows all those conversations to take place in one area, and appreciate the opportunity to try to make it work. So thanks again, Homer.
Okay. Well, it's almost exactly 2 o'clock. If there are no other questions, one final thing that I have is that we'd really like your input on what you'd like to see in terms of presentations. So we're going to be putting out Eddie's going to be putting out a survey here asking for your input. We've got some ideas, but we want to make sure that they're really the ones that are important to you rather than the ones that we think and might guess wrongly are of importance to you. So if there are no further questions, we do appreciate it. And thank you very much, and stay tuned for the next virtual student chapter presentation coming soon. Thanks very much, everyone. Take care. Bye-bye.
Thanks, Homer. Bye.
Bye.
Thanks, everyone.